Okay, we'll go through the important points in the class 12 chemistry, chapter 11 alcohols, phenols, and ethers. Alcohols and phenols formed when a hydrogen atom in the hydrocarbon, aliphatic and aromatic, respectively, is replaced by a OH group. So, alcohol has a OH group. The spirit is also a alcohol, that is ethanol. So we have aliphatic system and aromatic system. That is aromatic system has this benzene ring. Without that aliphatic system. So this is a ether, example of a ether. So only one OH group monohydric, two OH group dihydric, and these three OH group trihydric. So we have compounds with the sp3 hybridized carbon atom. So here this is a primary, only connected, this OH group carbon atom is connected to only one carbon atom. Here this carbon atom is connected to two carbon atom, that is secondary. Here this carbon atom is connected to three, tertiary. Lytic alcohols. Okay, here this carbon atom is connected to the other carbon atom which has a double bond. Okay, see here this carbon atom connected here with a double bond. So carbon atom adjacent to a carbon carbon double bond. So that is halide. And the benzylic alcohols, hybrid carbon atom next to a aromatic ring. Okay, this is the aromatic ring. So this carbon atom, this is sp3 hybridized connected to the aromatic ring. So this is benzylic alcohols. So if it is directly connected like this, then it is a phenol. Okay, this is benzylic alcohol, this is phenol. Direct connection, but through a carbon atom it is connected to the benzene ring. So here it is sp2 because this double bond here. Here also monohydric, dihydric, trihydric. So ethers we have in between the alkyl groups, we have a oxygen atom in between. So the primary, secondary. Okay, this OH group is connected to a carbon atom which is connected to only one carbon atom, primary. So here this is also primary. So here it is secondary because this carbon atom is connected to two carbon atom, secondary, like that. This is a methyl alcohol nomenclature. So alcohol ends with ol at the suffix at the end. So these are some alcohols with the IUPAC and common names. So here see how numbering starts. This is ortho position, meta position, para position. OH is in ortho, this is in meta position, is in para position. So this is how ethers are named. See last we have ether. There is common name, there is IUPAC name. See how the numbering from the functional group. Numbering start from the functional group, that is OH here. See here, see the bond angle in the alcohol. In case of alcohol, it is around 109 degree COH bond angle. But in case of ether, COC is around 111. Okay, this is important. Alcohol and ether bond angles. Okay, carbon-carbon bond angle. This carbon-nitrogen bond angle 109, 111. Why this bond angle? Due to the repulsion between the unshared electron pairs. Here this is for the alcohol. For the ether, this is the slightly greater than, we have 1 okay, due to the respect. Okay, you can go through the reason why the bond angles are different. Preparation of alcohols. This is a Grignard reagent RMGX. Okay, RMGX. This compound is a Grignard reagent. So this is phenol is also known as carbolic acid. How phenol is prepared from diazonium salts. This is for the interstitial preparation of the phenol for the large quantities of phenol and acetone, okay, from cumene. Physical properties. The boiling point of the alcohol and phenols increase with increase in the number of carbon atoms. Okay, boiling point increases with increase in number of carbon atoms. In alcohol, the boiling point decrease with increase in branching. Okay, more branching, then the boiling point will be less. Okay, so boiling point alcohol and increase with the increase in the number of carbon atom, but it decreases by more branching. So this boiling point is due to intermolecular hydrogen bonding. Okay, this is intermolecular hydrogen bonding, how it is formed. Boiling point comparison. Look at this. This is the molecular mass of alcohol, and here this is the this is 44 and this is 46. Comparable molecular mass, but here we have more branching here. That is why boiling point is less here, and this is more here. So more branching here. The high boiling point alcohol is mainly due to the presence of the intermolecular hydrogen bonding. Alcohol forms intermolecular hydrogen bonding. Solubility of the alcohols and phenol water due to the ability to form hydrogen bonds with the water molecules. Okay, this is water molecule H2O. It forms hydrogen bonding with the water molecule. So solubility is more, but solubility decreases with the increase in the alkyl aryl groups. Okay, solubility decreases with increase in alkyl and aryl groups. When you have more alkyl aryl group, solubility decreases. What is nucleophile, electrophile? You can go through it. Nucleophile is nothing but nucleus lover, so that means more electron rich. Electrophile is electron lover, that means is more proton is more here, more positive charge. Alcohols and phenols are Bronsted acid. Okay, they donate to protons. They can donate proton to a stronger base. That is the Bronsted acid. Acidity of the alcohols. Okay, when you have more R group, there are more electron donating. It increases the instability. Instability will be more when you have more R group. So the acidity decreases. So acidity of the primary alcohol is more than the secondary alcohol. Secondary alcohol more than the tertiary alcohol. So the water is more acidic than the alcohol. Okay, water is more acidic than the alcohol. Water is a better proton donor than the alcohol, more acidic. Phenol is more acidic than the water. Okay, water is more acidic than alcohol, but phenol is more acidic than the water because of this resonance. Okay, after losing a proton, it will form a phenoxide ion that is very stable carb cation. So more acidic. Phenol is more acidic than the water. We have a alkyl group and phenol. Phenol is more acidic than the alkyl group because this alkoxide ion no resonance in the alkoxide ion, but phenoxide ion we have a resonance. So that is why phenol is more acidic than the alkyl alcohols. If you have a nitro group attached to the benzene ring, that is more acidic than the phenol. Okay, so here you see this is a phenol and this is with the nitro group. Okay, that is more acidic, that is pKa value less means more acidic. Okay, so among this ortho para nitro, para is more acidic than the ortho, then that is more acidic than the meta. Okay, so here you see ortho, meta, para, you see acidity difference. Phenol, nitrophenol is more acidic than the phenol because of the electron withdrawing nature of the nitro group. See what is acetylation? The introduction of the acetyl group in the alcohol or phenol is known as acetylation. Okay, this is the acetyl group. So what is a Lucas reagent? That is HCl plus zinc chloride. So this test is used to differentiate between the primary, secondary, tertiary alcohols. Okay. Primary alcohol do not produce immediately at room temperature. Get tertiary alcohol immediately produces. Dehydration of alcohols follows the following order. Dehydration. Tertiary greater than the secondary, greater than the primary. Dehydration. I think based on this test. Proton elimination means removing H. See here H is removed. A better reagent for the oxidation of the primary alcohol to aldehydes is pyridium chlorochromate PCC. This is the oxidizing agent. nitration phenol to orthonitrophenol and paranitrophenol. Orthonitrophenol is steam volatile due to the intramolecular hydrogen bonding. Orthonitrophenol have intramolecular hydrogen bonding, while paranitrophenol is less volatile due to intermolecular hydrogen bonding. Okay, this volatility, intra and intermolecular hydrogen bonding. Okay, orthonitrophenol forms intramolecular hydrogen bonding, paranitrophenol intermolecular hydrogen bonding. Okay, intermolecular. You see here, inter, this is intra. See here, in case of phenol, the polarization of the bromine molecule takes place even in the absence of the Lewis acid. Okay, only in case of phenol. Okay, polarization of the in the case bromination, during bromination without Lewis acid, this polarization takes place. So here in this Gibbs reaction, we are using phenoxide ion instead of the phenol. The phenoxide ion generated by treating the phenol with sodium hydroxide is even more reactive than the phenol towards electrophilic aromatic substitutions. So phenoxide ion is more reactive than phenol electrophilic aromatic substitution. Hence it undergoes electrophilic substitution with carbon dioxide. So here we are using, that is why we are using phenoxide ion instead of the phenol. Methanol is also known as the wood spirit. Okay. So this is the how ethanol is prepared. Here we are using the enzymes that are biocatalysts. Enzymes are called biocatalysts. Inverters, zymes. These enzymes are we are using in this process. Okay. From sucrose, how ethanol is prepared using the biocatalyst, that is enzymes. What is denaturation? Denaturation. The commercial alcohol is made unfit for drinking by mixing it with some copper sulfate to give it a color and a pyridium to something smelling liquid. Okay, smelling liquid is denaturation of the alcohol. See, this is how the boiling large difference alcohol and ether due to the presence of the hydrogen bonding in alcohol. Alcohol forms hydrogen bonds. Okay. This is alcohol, hydrocarbon, alcohol and ether. The boiling point is more here for the same molecular mass. Alcohol in oxygen of the ether can also form hydrogen. Reactivity of the hydrogen halides. Okay. Iodide greater than bromide greater than chloride.